Hey, hey, everybody, good evening. We're just talking about how it's March, which means that it is that spring break's coming up. Woo! What people doing for spring break? Going someplace awesome, fun, going to let's see here. This is the West Coast. People will probably go to like Tijuana or something like that. No, I don't know. Yeah, I mean, I grew up in New Hampshire, and so then the joke was like everybody would go to like Florida, like Daytona Beach or something like that. And I was like, oh, it's so skanky. It's like, and this is like back in the '90s when it was probably maybe it's different now. I don't know. I don't pay attention. Probably not. Yeah. Anyway. Well, good deal. So we are heading really just into we'll get the final topic, which is Android development. It's the last couple of weeks of the course. So I just want to give everybody a preview. So tonight we're going to start talking about Android. I'm going to, the goal for tonight is to give you what you need to get started with Project 6. So as a start, not to do it, but just to make sure that your environment's set up. As we'll discuss, there's a different set of tools that you'll need to develop Android. Not terribly surprising. But luckily the tools oh, well, I would hope that the tools feel familiar because it's basically IntelliJ, but with Android stuff. And so then anybody who's playing along in real time, hopefully you can get stuff set up and get everything going along with us, or shortly finish up because it's really important. And I'll emphasize this again that you make sure that your development environment, your laptop or whatever machine you're working on, which cannot be a PSU machine, they don't have the Android tools on them. So the other development machine you use can run Android Studio, can run the tools, make sure everything works. So tonight will be introduction to Android. On Wednesday, we'll do our third and final mob programming activity. You can either be here in the classroom if you want to do some in-person mobbing, or you can be remote if you want to experience that. We'll be able to accommodate both. And I'm curious to see how all of that goes for everybody. And then next week is really the final content for the course. So we'll be doing some more Android programming. We'll create a very bare bones app tonight, and then we'll go through some activities next week that will evolve the Android app that we build. That basically I'm showing you to demonstrate some of the concepts you might want to use in your program in your project. As we'll talk about tonight, the Android project is very open-ended in terms of its functionality, or at least more so than the other projects. And then I just wanted to get on your radar a couple of things. So a week from Wednesday on the 11th, I don't have anything prepared for that. So we might do a little bit more Android depending on what we get done next. Sorry, on the Monday on before that. If there's a particular topic that you'd like me to speak on, I can try. If it's something that I'm familiar with or something I can do a little bit of research on. Also, happy to play with maybe some AI assisted coding or something. I've also got some ideas for things we could talk about, but I'm not ready to commit to actually having stuff ready by then. So that's kind of open. So we'll firm things up next week, but be thinking about if there's something that you'd like me to talk about. And then the final exam is on March 16th. So it's Monday during class. Please be here. And next week we'll talk about the details of the final exam. There's really not that much to it. And but please, make sure that you can attend in person. And then we're done meeting. And so the last session we're not meeting here, but instead I want you to use that time to get all of your coursework in so I can have everything graded by whatever it is the following Monday or Tuesday. I want to get done over the weekend. Um, uh, so I can have all your grades calculated. Make sure to give me final feedback so that way Jun Young and I can get everything done for you. So that's what the next couple of weeks are going to look like. Anything else I can tell you about the remainder of the course before we just open up for general discussion? Oh, cool. So, how have things been? So, I'm really curious about how Project Five is going with people. I apologize if it sort of felt that. I apologize if it's felt like we've been working fits and starts. I know it was like, oh yeah, introduce the project and then do some stuff for a couple of classes, then come back to it and stuff. But how are people finding it? Where do you feel you're at with the project? Is there anything that I can tell you or any questions that I can answer about Project Five and how it's come together? Any chats? No? Are people working on Project Five? Just making sure. Yeah, okay, okay, good, good. Hey, well, I've seen, yeah, I've seen things. It's like, yeah, okay, good, good, good. Yeah, so like, I guess what Project Five is due on Wednesday. I haven't had a chance to look at the POAs yet, so presumably people got those in and without too many questions. Let's see here. Yeah. Oh, and it's also a program note. I'm attending a conference on Thursday, Friday, Saturday, so I won't have the same responsiveness as I might normally. So I apologize if you have questions and I'm taking a little bit longer to reply to you. I encourage you to ask questions then in the Open Joy of Coding channel instead of IMing me directly. And get those questions in earlier because I'll be more likely to see them tomorrow and Wednesday. Excellent. Yeah. Anything else to discuss before we dive into Android? Okay. So, the final topic in the course is Android development. Now, I've always ended the course with user interface development. The beginning of the course is really all about learning development techniques like test-driven development and refactoring, and you're working with a command line application. In a language that's pretty new to all of you, and so that I've tried to keep it, the beginning of the course, is meant to be hopefully familiar-ish enough to you. So you're focusing on, learning Java, focusing on learning the Java APIs, and then, integrating test-driven development and all that kind of stuff into it, unit testing and stuff like that. But, command line programs, yeah, sure, people still use them, but, okay, kind of a solved problem. We know how to do them. Not nearly as interesting as something that's more interactive. And I really want to give my students an opportunity to write, a rich user interface. Uh, I've used several technologies over the years, and for me, a big constraint is that it's got to be something that you can do with Java. I'm not going to, introduce HTML and JavaScript and CSS to people here in the last like 3 weeks of the course. That'd be a little ridiculous. Because I want to focus, I want to continue to reinforce the fundamental programming patterns for objects and stuff like that you encounter in the first half of the course. I think it'd be really incongruent. All of a sudden, this course turned into web development. Plus, there are other great courses offered at PSU where you learn those skills. So instead, and so for the last couple of years, I've been doing Android, and it's worked out pretty well. Students have found that it's familiar enough that they can get their bearings pretty quickly, but it's also, there's enough new concepts that people can dive in and do something that feels a little bit more contemporary, a little bit more modern. So, your final project, Project 6, is a small device application developed for Android devices. So this is due March 18th. So you've got a couple of weeks to do this, starting tonight. And the idea here is that you'll take your phone bill application and from those pieces of parts, create an Android application. So, in terms of functionality, really the intent is that it has all of the primary functionality of the previous assignment. So, be able to, create and edit phone bills, formatting phone bills in a pretty way, searching between two times, saving to a text file, etc. We won't be doing database stuff in here. Actually, there's a tiny little database on the Android application on Android devices, but a text file is going to be fine for this. Um, and also be clear, so no database, no REST API. So the servlet and stuff like that, we could, but let's not. Let's just focus it on having an Android application that writes files to the disk that's there, so persistent storage that's there with the Android application. So I'm not going to go into a tremendous amount of detail about how Android works, the architecture and everything like that. That's all covered in this Android fundamentals lecture. which is definitely required viewing for the project. Be sure to queue up of watching that if you haven't already. Um, but what we will see tonight is the tooling associated with Android, and then time permitting, we'll also look at the code. So Android applications have what's called entry point. It's like the first screen, if you will, of the Android application. And it's akin to the main method in that it's where the program starts. And so there are some fundamental things that the entry point should have. It should have a help menu, so something that looks like a help menu. That's where you can see your README. So yeah, there's a README for this project too. It's not printed out to standard out, right? No standard output, no standard error in the Android app. Instead, it's something that needs to be displayed, on screen. So you still have your README. There's still error handling, right? Things can go wrong. And I encourage, well, and then please use a dialogue to pop it up. It shouldn't just crash. It shouldn't write something to a log file. If something goes wrong, like a date is malformed um uh or I don't know, there's an internal error, a null pointer exception or something. Make sure that there's a reasonable dialogue that pops up. Although dialogues, on screen should be used for conveying small pieces of information, like, oh, look, your date was malformed. Don't use a pop-up for your pretty printed phone bill. You'll lose some points that way because that's really hard to read and it's awkward. So just be judicious about about what widgets that you use for your project. Other than that, there's really not much in the way of requirements. So unlike, the command line projects where, yep, you had a command line, it was a certain format, et cetera, et cetera. Nope. The Android project is meant to be more creative, give you an opportunity to really explore the tools and the user interface widgets that are available to you. I will, and I'll probably go into this a little bit later, but it's like, if something is hard to use, you're going to lose points for it. Right. And so then there's creativity, there's also limits to creativity. So don't try to introduce a new user interface paradigm where everything is like just done with like shaking or something. Point and click. Let's, remember, old guy using it. So luckily you don't need the large font like my wife does. But anyway, and so then, just keep it simple. If you have any questions, reach out. Tell me, send me a screenshot or, hey, I'm always happy to, walk through something if you're concerned about it not being used. So, now what we're going to do is we're going to figure out how to get started with Android. And so what we're going to do now is download and install the tool set that's needed to develop Android applications for this class. So then we're going to go off script here. So I'm going to open up the nice. So, as you learn about in the lecture, Android is offered by this consortium of companies headed up by Google, so it's mainly Google, that provides devices and an operating system and an environment that runs in those devices. And, the nice thing about Android is that it's open and that it runs on hundreds of different devices, ranging from cell phones to devices in cars, so onboard media, to set-top boxes, to televisions, right? It's a very widely used set of tools for developing applications for small devices. So basically, the whole idea is that, yeah, fine, there might be as much power in my cell phone that they had for the Apollo mission, but still it's like a different device than, say, your laptop or a big server, or whatever. So if you go to developer.android.com, this is a great resource actually for learning about Android, for getting started with it. And what we're going to do primarily from here is download Android Studio. So Android Studio is a customized version of IntelliJ, of basically the JetBrains IDE, that is tailored and has some tools that you use to develop Android applications. So yeah. Next badge, fine, go away. Good. Okay, so I have read over this a million times, and so yes, I agree. I want Mac with Apple chip, and so I'm going to download that. Yeah, I get badges now. Okay. So just like you had to download and install IntelliJ on your development machine, you'll need to do the same for Android Studio. Oh, and things are a little big. Oops. Oh, it's resuming. Okay. Oh, not so bad. So, one of the first times I did. We'll be downloading a lot of stuff tonight because we'll be downloading Android Studio and then all of the development tools for Android, including the emulator and everything like that. And like the one of the first times I did this, we were in probably the old Neuberger Hall or something like that, which is now like the Mass C Hall, I think. Um, and the internet wasn't that great back then, the Wi-Fi, and like I had like 30 students in the class, and they were all trying to download at the same time. Someone actually like walked across the street to the Starbucks, used their Wi-Fi. It was faster to download than was here. So anyway, so if people have problems downloading, I apologize. The last couple times I've done this though, it's been fine. Okay, so I downloaded the installer for my Mac. I'm going to run that, and I'm just going to install it into applications. It'll do its thing. Yep, it made its noise. That was nice and fast. Great, Android Studio. Yep. Okay, so I downloaded that. Okay, and it pops up. Now, so Android Studio, once we get through the setup stuff, we will see that it looks a lot like IntelliJ because it is IntelliJ. But the nice thing about it is that it really guides you through installing the Android development environment. And so all the development tools. Uh, you know, 5+ years ago, this process was super awkward. Always had to like go like find random articles posted places in order to figure out all the steps. They realized that pretty quickly that was a barrier to development, and so they made it a lot easier. So, it basically has a nice wizard for getting started. And okay, yeah, we're not going to have any existing Android apps. Okay. Just choose the standard. Install should be fine for everybody. Maybe some of you will have to go back and do something standard. But like I hope not. Sorry, I have to do back to something custom. It's telling you that, hey, there's a bunch of stuff that's going to download and install. I'm going to get this started and then we can walk through it, talk about all of the various things. Yes, I accept all your licenses. So both for the software development kit and then, well, there's, special libraries and stuff like that for the Mac for my machine, and we'll get started. So while this is running, I'll explain a little bit about how Android development works, what all the pieces parts are. So, as you'll recall, like in Java, you downloaded the IDE to, write source code and sort of build the application inside that development environment. But then you also had to download the JDK, right? That's the Java development kit, and so that's the series of tools like the Java compiler and the Java VM and then Javadoc, all of those things to run a Java application. There's things it's very similar with Android in that in addition to Android Studio, which is the IDE, the integrated development environment, there's also a bevy of tools that are used to build and run Android applications. So Android itself is there's essentially a virtual machine that runs Android applications. So it's akin to Java in that you have your source code, you build that source code into an Android application, the APK or whatever it's called now. That file then can be run on any Android device with a compatible runtime. So the picture that I have in my head is very much like with Java, where you've got class files that run on any JVM. You've got an Android application that runs on any device. And of course, each device will have its own unique characteristics, certainly its size and form factor, but maybe also the capabilities of that device. Some devices will have things like geolocation and will have things like accelerometers and stuff, and some won't. And so then, your application, depending on what devices it's supported on, if it wants to use, some of those things, it might need to check to see if the device that it's currently running on supports it and go accordingly. Oh, nice. Okay, that was nice and fast. So I have, I've downloaded and I started up Android Studio. Now I am downloading and installing the development kit. Okay, and now we're at the next phase of Android Studio. Now, this looks familiar, or this might look familiar. Oops, looks like Celine just woke up. What just happened there? That was weird. Okay, so Skype came to life here. Okay. Yeah, yeah, yeah. Oops. Um, Now you're in Android Studio, and just like IntelliJ is asking you, hey, you want to create a project. And so we're going to want to create a project here. Now, let's see here. We want, and this is we want the empty views activity. So there's basic views and there's empty views. Because we're writing Java applications. It's okay, sorry. Let me back up a step. Android Studio out of the box comes with a bunch of templates for creating projects. And you can, this sort of helps get started. And as you can see, there's like, okay, you can create C++ ones. You can create these what are called, empty activities, an application with no activity. And activity is basically a screen inside an Android application. Uh, and so, okay, oh yeah, and I guess it's just sort of phone and tablet ones, but hey, you can also create, default car ones or for, a television app or whatever. That's neat. We're just going to be doing phones in this class because it has a nice size, and I think it's a good place to start. So you want the empty views activity because that's the one that lets you actually create stuff in Java. Android, if you read about it, if you look at examples, Android, okay, so politics and lawyers and stuff. So there was a time, so Android sort of came about when Java was still, very open, and I had Sun been bought by Oracle yet? I can't remember. But Google was initially all in on Java. They loved Java. They did lots of stuff in Java. And then when Oracle bought Sun, and all of a sudden Java was owned by Oracle, and Oracle wanted to get money out of Java because it's like, well, we bought this company and it is good stuff, so people should be paying for it. And so then there was all this bad blood for a while between Google and Oracle and kind of control over like, hey, can you really use the trademark Java because we've got a trademark? Or hey, those libraries really aren't yours, yes, they are because of this license and stuff. So the Android folks sort of protected themselves from the Java lawyers, came up with an alternate language called Kotlin that also can be compiled down to an Android application. So you'll see this thing called Kotlin all over the place, Kotlin. Um, in Android examples, and when talking about Android development, Kotlin is actually probably the preferred language from the Android people. Again, I'm not going to spring a new language on you in the last 3 weeks of the course, so we want to do things in Java. Long story short, the only one of these templates that supports Java out of the box is the empty views template. So create one of these. So okay, there you go. That's why you create an empty views activity. Okay, and now it's going to prompt you for some information. So the name of the application is going to be phone bill. And the package name is going to be your package name. So, oops, edu, pdx, cs, joy, and then your name. So mine's bitblock. The location, okay, so this is where the source code is going to live. So what we're doing here is we're generating the application. So in the command line projects and the rest project, you use a script on the Unix machine to create the Maven project. For Android, you use this to create the project. And actually, it's not Maven, it's something called Gradle, but I'll talk about that later. And we want it in this directory right here. So we want it inside of our repository for our projects. And we are going to want to call it phone bill -Android. Actually, this is really important, right? So you want your source code to be in your repository, so that is under version control, and you want it there because the submit script knows to look for a phone-bill-android directory. We want the Java programming language. And okay, there are all these different versions of the Android operating system API. I don't know what we gonna call it exactly. Versions of Android, of the Android runtime, maybe is the best way to put it, that are available. We want a relatively new one so that we can use new Java language features. Let's choose 35. And then build configuration, we want this to be Gradle and not Kotlin DSL. So, sorry, Groovy DSL, not Kotlin DSL. So just again, if you're playing along at home, the name of the project should be phone bill. The package should be your package name. The location should be a phone bill dash Android directory inside your the checkout of your GitHub repository. The language should be Java. Minimum SDK version should be 35, and the build configuration language should be Groovy DSL. Yeah.
All my class.
Oh.
All my class file had voice the root directory in my class file.
Right.
That was class. It says also not any case. I have a problem with that. You know,
I don't know if it will have a problem with that or not. Are you on Windows? That's a Mac. Is that Windows or a Mac? I can't tell. Okay. Oh, really? Boy. Yeah, maybe. Yeah, maybe. Yeah. And actually, I mean, worst comes to worst, you just sort of move things to a different directory without the space in it. But yeah, yeah, and it's probably more of a problem on Windows. I've found that Macs usually are okay with spaces. Unix-based machines are much better about spaces and file names. But yeah, it's probably warning you for a reason. And so then, yeah, just well, actually, we'll probably find out pretty quickly whether or not it works. No, great question. Yeah, because actually, point if I put a space in here, what do I get? Oh yeah, there it is. Okay, NDK. Okay, so all this stuff and click finish. So it goes off and generates some source code. It will ask me if I want to add them to Git. I do. I would expect there to be more than that. I'll say don't ask again. Oh yeah, there you go. Lots of stuff that gets added to Git. Yes, the build.gradle. Yes, I'll put all that stuff under Git. Wow, this machine is so much faster than my old one. It's great. Okay, now it's generated the source code. And I want to talk a little bit about the project it's created. So, in the rest of the course, we've been using Maven to build Java projects. And Maven's great. I love Maven because it just sort of like gives you, to me, it just seems like a really straightforward system to use. There's lots of rules because I don't want to have to like worry too much about my build system. I just want it to work. And so once I get it to work, it stays working. There is an alternative to Maven called Gradle, which is for me the big difference is that Gradle offers a lot more flexibility. For me, I don't want I want just enough flexibility in my build system. I don't want to have to like make files drive me crazy because it's just like this is too hard. Why am I have to worry about tabs versus spaces? Why do I need to like come up with all this stuff? It's like no, I want there to just be a nice standard format that I can follow, and then I'll worry about my building my I'll worry about authoring my application, not how it's built. That being said, there are a lot of things in Maven that certain people found to be not great, and so they got together and created an alternative called Gradle that uses configuration files that are written with a language called Groovy, which is basically is another language that is compiled to the JVM that offers a much more loose syntax, and so you can build what are called DSLs, not dynamic software languages. Oh shoot, what do they stand for? Domain specific languages. Thank you. Domain specific languages for for building. I gotta admit, personally, I've never taken the time to really learn Gradle. I know just enough to be dangerous in it. And so then, but luckily for this class, You won't need to touch anything. There's actually one change that you need to make for a Gradle file, and we'll talk about that next time. Okay. So then, oh, this is interesting. So it looks like everything built okay. There was a pop-up here a minute ago saying that it didn't know what JDK to use, but it seems to have found stuff. Okay, yeah. Okay, yeah, so maybe it found one in the default. Oh, nice. Okay, so you're seeing some stuff. So let's, yeah. So what are you seeing right now?
Still have a bunch of stuff, like like a Gradle executable, like. Yeah, build up Gradle properties, and then like once, this is for Spencer, like when it's loaded, like all it's gone, all of it's condensed, but now it looks like yours.
Now, yeah, okay. Yes, and I think one of the things that seemed to happen automatically is that like the JDK was chosen. So like there was a pop-up that said, "Hey, you don't have a version of Java defined," which you may recall like when you installed IntelliJ, you probably saw the same thing and you had to go like download and stuff like that. It must have automatically detected something and chose it. But are you seeing it or not? So it's like are you sort of right and just like poof, everything was fine. Okay. Interesting. We'll see if things work. It probably will. So so you know your IntelliJ is happy because sorry, your Android Studio is happy because it's showing you this app view of your application. So and again, Android Studio is built on top of IntelliJ, so this would look very familiar to you. It's got a lot of the same things like commit changes. Oh yeah, right here it's added a whole bunch of stuff to Git, hasn't committed them yet. You can navigate the project here. There's this new view called Android, so you can look at like the project view like we had before for your Java code probably. But the Android view is nice because it really focuses, well, we'll see how this focuses it on on the application itself. Um, yeah, and such. Okay, well, so we've got this all out of the box. And again, every time I don't develop Android applications, for a living, and so I don't use these tools. The only time I use these tools is when I teach, and so it's always interesting to see like what new things are available in new versions of Android Studio. So boy, it's a lot faster to get up and running than it was even 6 months ago the last time I taught. So it looks like everybody's environment is doing okay. Okay. So what you get out of the box is this Android application. It's a simple hello world, and now we're going to run it. Now, when you run an Android application, you run it on a device, right? You don't really run it on like, you don't go to the command line and say, run Android. It's, my Mac is not an Android, not an Android device. Instead, what you need is a device that you can run it on, and so you can see how it's displayed and you can interact with it. And so then what Android offers is emulators for really every device that is supported. And this is kind of a mutually beneficial relationship between well, if you are a device vendor, so let's say you're selling cell phones or you're selling t smart TVs or anything like that, you want people to develop apps for them. And so what the device vendors will do is provide software emulators for their device so that app developers can test their applications on their devices. And so there's a device that comes out of the box, but we want to run a very specific device for this course. So out of the box, we get this Medium Phone API 36.1. That's neat. We're not going to use it. Actually, I'm going to go and delete that. I'm going to delete that device. You can do the same just so it doesn't confuse you, or you can leave it if you want. Yep, I'm going to delete that device. Okay, by the way, I went over to the device manager here on the right. So one of the things that the Android development kit does and Android 2 makes it really easy to manage is all the emulators that you have. Now, in this course, we're only going to have one emulator, but you can imagine you do this professionally. You're going to want to target a number of different devices, so you probably have a lot of emulators that you could run and that to test with. So you're going to go into the device manager and you're going to create a new device by using this plus icon. I'm going to create a virtual device. You can also configure Android Studio to work with a remote physical device. So hey, if you have an Android phone, yeah, you could deploy your application on there. I think you can deploy it over Wi-Fi or plug it in with USB or whatever. Some students have done that. It's been kind of neat. It'll be much faster to use a virtual device though than having to port it over to your device every time. So you want to create a virtual device. We're going to do a Pixel 9, so well, pretty much the latest Pixel version. And we are going to choose that API 35, the vanilla ice cream again. And we're going to call it Pixel 9 API 35. Let me just double check that. That's what we're supposed to do, right? Oh no, we're going to use 36. Okay. Sorry, the project itself will work with 35, but the emulator will have 36 on it. That's good to know. Yeah, 36, 36.1 probably doesn't make a difference. And so what you're doing is you're creating and configuring the virtual device. This is probably all you need to provide, but just so you can see, you can configure things like hey, does it have a camera? And oh yeah, what is there any network latency? And just other things like that. That when it comes to how many CPU cores and stuff. So this is all part of what the emulator gives you. Is really lets you see what it's like on a real device. If you want to do something like constrain its RAM, or whatever, you could. And I think this is a really powerful thing about Android, the fact that you can really work with real world devices in pretty much a real world situation. So again, we're going to create a new Pixel 9 device for API 36. So choose API 36 and talk about the system image and stuff like that. Okay, so click image. And now it's going to say, yeah, do you want to, download stuff? So, the idea here is that the emulator is software also, and so it needs to download that software. It's a pretty big and kind of slow image, as I recall. So it'll take a while there. Should have been doing this for the last 3 minutes while I was gabbing about all the stuff about emulators. What else can I tell you about emulators? Well, it's much more cool when you see it. So the whole idea here is that in addition to using Android Studio to develop your application, to write your source code, to compile things, you also can use Android Studio to manage and run your Android emulators, and then the build process for inside Android Studio will compile your code and then deploy it to your emulator. Much like in a way, in that you've got this container, this other piece of software that then runs your application. Conceptually, this is very similar in that you've got this emulator software that runs your Android app that you build. How are other people doing so far? Is everybody else like, what? We should be sharing from your machine then, yeah. That's okay. I'm just waiting here in line.
Right. Different emulators wouldn't impact what the business option would be.
Oh, great question. Emulators, like using a different emulator ought not to, shouldn't, impact it. What it would impact is maybe the display, right? If the displays are different sizes, especially if they're like, you've got a tablet versus a phone, right? That would impact certainly the look and perhaps some aspects of the behavior. Think of your favorite app that you use across multiple devices. For me, I think of YouTube, and how like YouTube on a tablet, it's different. Now, I don't know if under, behind the scenes, if that's really the same application or not. I think it probably is. And so probably there's logic there to say, oh, look, when I am, running on a phone and I get rotated, okay, I'm going to behave this way. Or, hey, more likely it's like, oh, I know my screen is smaller. So like when I'm in portrait mode, certain things are going to be hidden. And then when you turn it to landscape mode, certain things get revealed because there's just a different kind of real estate available. And then, oh, look, same application on a tablet, yep, more screen real estate, perhaps more memory or CPU also available to it. So certain features, might be available. I can imagine for games and things like that, where, there might be certain aspects of the experience that are different on a different device.
One, there's in Mario 64, there are different types of like emulators that are used for like game speedrunners. We'll have like ports that are in one version but not the other.
Well, exactly, yeah. I hadn't thought about like game emulators, but it's kind of the same thing, right? Where you've got yeah, you've got the bits from a million years ago. Those are still good, but the hardware is completely different now, and so then yep, you need an emulator to do that. Do you have a question, or is that just no? You're good.
Yeah.
Okay, nice. Okay, so it finally installed. This is good. Okay, and now over here in my device manager, I see I have a Pixel 9 API 36 device. And so I'm going to click the start button. And this starts up the emulator. So the first time it starts, it's actually literally booting up a phone. And so then the first time it's got to initialize a bunch of stuff. Uh-oh. Not enough space to create a user partition? Really? Really? I didn't. Well, I mean, is it like disk space? That's surprising. No, I've got plenty of. Oh, wait, no capacity. 99%? Wow. Seriously? That's good. That's okay, that's surprising. Well, now I just go like let's see here. I don't think there's anything here. Okay, we're gonna pause while I clean up my machine. We don't need to see this. Okay, well, that was like super weird. Sorry about that 10-minute distraction from what we were doing. So I finally got the emulator to start up, which I think a number of you have also. And so then, as you can see, you've got a phone running on your machine. Now, I like to undock it so it can be bigger, and so I can sort of see things a little bit better, and so then you can make it a little taller and stuff. And it's a phone, and it's got apps, so you can do things like run Chrome here on your emulated phone. So I'm not going to log into an account or anything like that, but it's actually real Chrome, just as if you were running on the machine. And so then you can look, yeah, I don't want to try out my stylus. And oh, it's interesting. It's got something on the clipboard. That's funny. Oh yeah, of course it does have something on the clipboard. So you can just go to, you just go to the PDX website, and you can see this here on your phone, and you can interact with it. So I can click and drag, to move stuff, and click, as if you were tapping. And you can do all sorts of stuff here. You can rotate the phone to see how your app behaves when it's rotated. You can control the volume, and you've got the three buttons that that they use to interact with Android apps. And so then you've got the overview button here, so you can end apps like that. You can go back to home, which I'm already there. You can go back. So like, and we'll see that in the apps themselves. But anyway, so this is this is the emulator environment, and it's basically a real phone. And you can do things like take screenshots. You can enable the screen recorder, cool stuff like that. And it does. You can configure it so that it uses like your PC phone, your PC microphone, your PC camera, and stuff as input devices. So that's the emulator itself. We can also do in Android is you can run your app on the emulator. And so then just like in IntelliJ, there's the run button. So this will go off and build your app and then deploy it to your emulator. And there it was. So your app just started up and it says hello world. So that is the app. And so you can use the square button to go back to the overview. And you can, well, you can end it that way. Oops, you can end it that way. If you can drag it high enough, there you go, to get it off the screen. And then when it installed with this little green Android icon, so you can click it again to launch it. And I think that some of you already discovered how to do this, and it seems to be working for you. So that's nice. Now, let's take a look at the code. Actually, before we look at the code, anything you want to talk about with regards to sort of the Android runtime environment or how to use Android Studio to get this far? I heard you guys like oohing and ahhing over what you're doing. Yeah, no, it's cool. It's cool. Glad it was working for you. Anything interesting that you found or anything you wanted to amplify or share?
In the, if you under resources, layout, activity main.xml,
Yeah.
you get basically, so we're in the game development, and it looks a lot like a game development, like
Yeah.
engine we use. Um, with like the component tree and it's just like the components, like there, it's like enemy bar, it's very cool.
Yeah, we're gonna look at that right now because yes, exactly. That's like the Android Studio side of developing the app. Nice. Thanks for looking ahead. Oh my goodness, in dark mode. Sorry, can you see that okay? Yeah. Yeah, I forgot to, let's see here. Let's see if I can figure out settings, dark, general, dark.
Feel bad. So here it's.
Oh,
uh,
huh?
Oh. It's so, it should be, that's what I go with here.
Oh, good. Theme, islands dark, islands light. Okay, that's better for me. Flashbang. Nice. Cool. I'll make that just a little. Whoops. I think we'll make it a little bigger. I'd like to make it a little bigger. No, I can't. Let's see here. And then settings, not plugins, settings, and size, font size, key map. Oh, here we go. Increase font size. It says that it is shift. Is that control shift? Period. Period. Control shift period. No. Does that work here? Control shift. Oh, there it is. Period. Nice. Okay. Good, good, good. That's a little better now. Okay. Yeah, let's look at the source code. So here's our app. Hello world. Okay, very straightforward. So in Android development, and it's, well, I mean, you see the same kind of thing in even web development. There are certain languages and tools that are good at expressing logic, and there are certain languages and tools that are good at expressing layout. And as it turns out, at the end of the day, everything is a Java object. But in terms of expressing like what the layout is, what the widgets are, it's much easier to use a language like XML, which is hierarchical in nature, which is is just descriptive, than it is trying to write all that stuff in Java. Like the very early versions of Android, you wrote everything in Java, and it was cumbersome to say the least. But you want to use Java for the stuff that Java's good at, right? For application logic, for responding to clicks, things like that. So your Android application is a mixture of Java code that performs operations in response to what the user does, and XML that lays out the various screens of your application. And so let's take a look at, and these are all in various files. So let's first take a look at the Java code here, and note that it's got source code and unit tests and something called Android tests. By the way, you've already demonstrated that you can write tests for Java code. So congratulations, no more testing. You don't need to write automated tests for your Android applications. You can, but it's not a requirement. I want you to focus on working with Android and not necessarily testing Android. If we were doing this for real, or if this was a 11-week course in just Android, sure, we'd be diving into testing. We'd be doing all sorts of great stuff like that. In 2.5 weeks, we can skip the test for now. So really, what you'll be working with is just the main source code here in your main package. So there's this thing called an activity. So the activity class is the Java code that backs this screen, basically. And so all it's doing right now is essentially enabling, bootstrapping, for lack of a better word, this application. So it's basically saying, hey, I'm the main activity, and so when I'm created, yep, you can look at the lecture notes to see what onCreate does and what the bundle is all about and stuff like that. But it does a little bit of, I'd say, Android-y things. Use a little bit, use some Java APIs to do some stuff there. But then that's it. It's pretty straightforward. So that's just, initializing the code. As was pointed out, the interesting stuff is in this activity, XML, activity main.xml. So for the main activity, this is associated with an activity underbar main XML file. And actually, let's take a look at the XML first. Here's the raw XML here. So this is XML that describes the screen, and so it's got one widget in it, a text view. Yep, and there's text view, and it has text of "Hello World," and there it is. So we can do things like change this to "Hello Class," and then we can rerun the application, and so that rebuilds it and redeploys it. And now it says "Hello Class." So these, and we'll see more details about this later. There are these XML files that describe how the application is laid out. So let's see here. This I changed to hello class. Oh yeah, and it got highlighted in yellow because it's saying the following: hardcode string hello class should use @string resources. Yes. So one of the things that I think it's covered in the second Android lecture where we talk more about UI coding is that it's good practice not to have hardcode strings, hardcode display strings in your XML files. Instead, what you want to do is extract those out into resources that can be localized and be translated and stuff, right? Even more so than command line Java apps or web websites. You definitely want them to be localized. Android apps, you want your app to be able to run anywhere in the world, and you want to have a familiar experience to the user, no matter where or who the user is. This is just good usability, right? If you want your software to be used, you got to make it usable. So then I don't really go into a lot of details here, but there is this there's this mechanism for extracting strings, and Android Studio makes it really easy to do this refactoring. So you can click extract string resource here, and it will create this resource in this strings.xml file. And now instead of that hard-coded string, it refers to this string slash hello underbar class, and you can navigate off to that. And so here are a bunch of string resources. It's another simple XML file that basically has all of your hard-coded strings. And what you can then do is you can have multiple, you can translate these strings into different languages. We're not going to do that for the project, so I'm not going to show you how to do it here. Although I guess it is, it is telling you, hey, you can open up the translations editor here, and so then you can say, hey, here are all the things that need to be translated, and I guess this will allow you to, add various locales and stuff, which would be a neat thing, but beyond what we're doing today. Okay, so we've got the main activity here. I'm going to go ahead and commit all this code, and you can just do the same way that you did in IntelliJ. So added Android application, commit push. And so Hooray, has a very familiar experience. 8 warnings and 1 to do. Sure, I'm sure it's fine. And as you can see, there are a gazillion different files here. I'll just take a quick moment and I also got some changes to Phone Bill REST client. Okay, we'll see about that. Let's see here. Let me just go through and highlight again some of the files. We talked about the Java file. Oh, the manifests. You won't need to change any of this stuff, but this is much like your web.xml. This is the manifest. This is a description of the application. And it has things like, here's the label, which is again that translatable name. The label, I'm pretty sure, shows up in if we go back to home, I think it shows up. And if we scroll down here, oh, whoops. Oh, I guess it would be the name of that. Oh, is that what it is? Okay. Oh. Oh, okay, there you go. Nice. Yep, here it is. Phone bill. Thank you. Oops. I clicked on it. Yep, that's where that shows up. You can also have like the icon and stuff like that, that you have there. And so if you want to mess with that, cool. It also tells you sort of where the application begins. So you can define various activities in your application, and as we'll see next time we get back to Android, we'll be creating additional screens of different additional activities, and they all need to be listed here in the application manifest. This is so that the Android tools, the compiler and stuff like that, knows what your activities are, so it knows what to compile. One of the things that's much more important with small device applications than it is with applications that run on servers, is that the code be compact. Right, you are on a device with limited resources. You are downloading things over the internet, and even though, yep, here in Portland, Oregon, in 2026, we have really fast internet. Not everybody has that. Again, you want to make sure that your applications are accessible to all of your users, no matter where they are in the world. And so then Android has a bunch of analyses that I can do to figure out exactly what code is used. And so then only that code is included in your application. I guess one of the things that I didn't mention, but I want to be sure to highlight, is that there's a Java runtime here. And so the vast majority of the standard Java libraries are available to your Android applications. So things that you're used to from like the Java util package or the date formatting classes or the IO classes, we'll see some of that next time, are all available to you in in your Android applications. And the build tools don't want to include like the entire JDK. You don't need all of the oh, I don't know. What are some things? Anyway, there's lots of stuff in the JDK that doesn't need to be included in every Android application. So it's smart enough to figure out what code that you need. Code that you need. Let's see here. And then there's resources. And here is where you can have information about, yep, great. So it turns out like the icon is actually two images superimposed on each other and stuff like that. The layout, we'll see that a lot too. Also some information about, I guess you can have a light and a dark theme, which is cool. This is also out of the box. And you know what? I encourage you to experiment with this stuff to a point. So, ultimately, what you're graded on for Project 6 is the behavior of your program. The look and feel, great, but if you've got like really a pretty looking user interface that doesn't work, you're going to lose a lot of points. So make sure that the phone bill capabilities are there and that they're working, and that you balance investment in the core behavior, core functionality of the program with having something that looks, that is usable, that looks nice, that you're proud of. Anything else I can tell you about sort of the application that we've seen so far and how it all works? I'm going to go back here and sort of talk more about all this stuff. So, right. So once you've got an Android Studio all set up, you've created your application. Oh yeah, you will need to copy actually, you probably don't need to copy the test code. Definitely need to copy the source code though for classes like your phone bill and your text dumper, your text parser, all those kinds of things here. We'll talk more about this next week. You will need to add one line to the app.build Gradle, and it's a new implementation line that adds the project dependencies. This is what gets you like abstract phone call and abstract phone bill, things like that. Oh, one of the things I didn't emphasize is that there's a POA for this project, but POAs are text. I encourage you to draw out what you want your UI to look like so that you can experiment and figure out what widgets you want on which screen and how things should work, how the interaction should work. There's a really, really nice tool called Balsamiq, which, gosh, I think that's still around. Yeah, it totally is. Great. that this thing's been around forever, and I really like it. It's really solid. It's for just making really simple mock-ups. Counts as it's hand drawn, but you can draw on your computer. It gives you a nice idea of what your UI might look like, and so I encourage you to check that out if you want to do a little bit of design there. Um, and oh, note if dates and times are input as text, which is fine. You can do it that way, or you can use a widget for choosing those things. The format of the dates and times should be the same. So 12-hour, yeah, 12-hour time with AM PM. Okay. Um, Again, the application, your Android app should have the same functionality as, let's say, your Project 4, plus the ability to search from, sorry, same ability as your Project 3. No database stuff in Project 4, but Project 5 added the ability to search. You're going to need that also. Another important thing to note is that the data that is managed by your app should survive the app closing. So unlike, say, your servlet where you stop Jetty and everything goes away, now here I want you to write out the contents of your phone bill or phone bills, actually phone bills. You'll need to manage multiple of them. Write that out to files on disk. And so one of the tests will be I'll add some stuff here to your phone bill. It's managed through the app. I'll then kill the app and then restart it, and I expect that that phone bill information will be reloaded there. And we'll see more about this next time, but Android has this mechanism for called internal storage that you can use for persisting. Here's how I'm going to build and run your programs. I'm not going to take your source code and run it in Android Studio. Instead, I'm going to use the command line tools. So I'm going to run Gradle to build the project. I'm going to exclude any lint tasking. And so Android has pretty serious lint stuff, right? Sorry, lint is just like a tool that warns about bad programming patterns and things like that. Professionally, if you're doing it for real, lint's great. And you should pay attention to these things, but for the purposes of this course, hey, if you get something that works, that's good enough for now. Um, and again, since I won't have any, there are no automated tests that are required, and so there's no code coverage requirement for the Android project. Same thing with API documentation. You have demonstrated that you can write API documentation by now. Here again, focus on Android and have it be fun. Then I'll run the emulator like this, and then I will install the application using install debug onto the emulator, and then I'll play with it. Note that I will be the person who grades this. Ju Young will do the final exam, and so then I'll spend some time over the weekend clicking through all of your projects. And then once I've run my grading script, then I'll use uninstall all to uninstall a particular student's application before running it again, but running the next students. So that's generally how I'll be running it. And so then if you're paranoid or you want to make sure that the program works the same, or that these steps work the same for you, you can follow them. Finally, a note about submitting. The department's Linux machines don't have Android tools on them, and so then you'll need to find a different machine to run Android Studio. And so hopefully the machines that you have access to, either your own personal ones or there might be other stuff in the Linux in the the Windows lab or something. I'm not sure. Anyway, so you got to find a machine. This is why I wanted to get everybody started a little early before Project 5 is due to make sure that everybody's got the setup that they need to be able to run the device. Yeah, so then, oh yeah, and also as a consequence, I'm going to grade the assignments on my personal machine. And so then that's how I'm going to grade things. And however, you still submit them in the same way. That way I can use my same submit process, and I'll make sure that all the stuff is recorded appropriately. And so then you'll say submit.sh project 6. And the submit script knows that when project 6 is specified, it will submit the phone bill Android directory. And note that for project 6, the submit process is much more lenient about what it will submit. So your your Gradle files will be submitted, any XML, any icons or whatever, that should all be submitted there. So if you want to add some more stuff, great. Hey, if you want to, if you want to add additional libraries, go for it. In the past, there have been a couple of times where students have added libraries that I've had to go in and like make some additional changes from what's submitted. So if you are actually, if you really want to dive into this and use a bunch of third-party libraries, let me know and we can talk and make sure that I can build the application on my machine without additional configuration being necessary. But that's it. So stuff there. What else can I tell you about the Android project? Anything else you'd like to know? Anything, any immediate thoughts spring to mind that you'd like to explore? Cool. Okay. Um, let's take another 10 minutes and just get started on adding some new stuff to the Android application. So what I'm going to be doing next week is, or yeah, I guess it's next week, is adding widgets to the Android application to build a very simple calculator program that adds two numbers, but it sort of shows you all the pieces, parts that you need to build an Android application. But let's just dive in by making a simple change to the Android application, just to sort of see how things work. So I'm going to go back to the layout. And actually, we were looking here at the raw XML, and I think as people were pointing out, there's also a design mode here. So I'm going to put things side by side. So over here on the left is the XML, and over here on the right is design mode, and they have both sort of light and dark mode, so you can see what it looks like. That. And here I've got a widget. And so one of the things that you learn about in the UI lecture is that there are these layouts that control how widgets are laid out on the screen and widgets inside containers and things like that. And what you can do is you can if you want to add more widgets, we're going to add a button right now. And we're going to and to do that, yeah, you could edit the XML directly, but that's kind of awkward in many cases. So what you can do, I'm just going to actually let's go back into like full design mode here so we can see more things. There's this palette over here on the left, and then over here on the right is I'm just going to hide that thing. It's so obnoxious. Hide video panel. Over here on the right is information about the thing that is selected. So right now we have this text view that's selected. The component tree is over here on the left. And if we expand the attributes, here are the attributes. Okay, they have declared attributes, and then you can go find additional attributes of the widget. So if I go back and look at the XML, it's not going to all fit, is it? Attributes. There you go. So you can see that here the declared attributes are everything that's basically non-default, everything that is overridden here in the XML file. Okay. I want to add a button here, and so then I'm going to use the palette to add a button. Just a plain old button, and I'm going to put it here. Now I added the button, and it's got a it's got a little exclamation point here saying it's missing constraints, constraint layout. Check the badge for details. So, okay, I clicked on it and it's like, oh, yep, it's got a couple of warnings. Hey, it's got hard-coded text and also it's missing constraints, constraint layout. And it tells you what's going on here. So it's like, right now the design view makes it look like it's floating here, but if we actually went and ran it, we would see that it's up here in the top right, no, sorry, the top left, because we haven't constrained it. So if we go back and look at this hello class, you see how it's got these accordions that basically say, hey, it's gonna, it's centered because it has, you can imagine these, well, not accordions, but springs maybe is a better word for it. Springs that are keeping it centered there. So we want to add similar springs to this button. So we're going to put this guy up here, and I always get this wrong. It's always super awkward for me. And we're gonna have that there. We're gonna have this here, and we're gonna have that here. Nice. And I think then that puts it there. That ought to be constrained, right? No more warnings. This is good. And it's also got, oh yeah, it's also got hard-coded text here. Can I fix this? Oh, I can. Extract string resource. Awesome. Resource button, sure. And I'm going to say, well, actually, I'm going to say button resource will be say hello, because that's what this clicking this button is going to do. Let's say hello. It's going to put in strings.xml. Nice. No more warnings, no more problems. Excellent. Let's run it again and see what happens. Great. Now it's laid out. Okay. Now when I click on it, it doesn't do anything. So let's make it do something. So UI development is, I think of UI development as just having some fundamental differences between like command line programs. And it was a lot like what we found with the servlet, right? With the servlet, you've got this Java object that just sort of sits there waiting for someone to talk to it, waiting, it's sitting there waiting to respond to an HTTP request. UIs are very similar in that the UI just sort of sits there until the user does something with it. Right. Well, maybe you've got some background processing or something like that. But mainly, what it does is it says, hey, listen, okay, here I am, look at me and interact with me. And so what UI development is event-based development, in that what your code does is it responds to an event. Your code is executed in response to the user doing something. And so a big part of a UI development, really after you've laid out your UI, is writing code that responds to interaction with UI. Like, oh, look, this button was clicked, or text was input here, or I reorient my device and I'll do something in response. So what we're going to do here is make it so that when we click the say hello button, a little piece of text thing called a toast will pop up, and it'll say hello. So what we need to do is we need to tell the UI what to do when the button is clicked. And the way that we do that is we are going to, let's see here, we're going to search for on click. Yes. Okay, we're going to add an attribute to our button called on click. And here we are going to, we need to give it a method name. So we're going to call it say hello. And actually, does that work? What is it? It does not like this now. On click method does not exist. Oh, and okay, sorry. Just say hello. Nice. Method does not exist. And so, oh, interesting. Okay. So now I think the error handling is better in the XML. So let's see here. Say hello. So we're basically saying, listen, when you click this button, we wanted to invoke a say hello method. And so now I can create the on-click event handler. And what this does is it adds a method to the activity that backs the screen. So this is what ties the layout in the XML to the Java code in that main activity method. And yep, I want to use the main activity. And it generates a say hello method. Now, what gets passed in is the button that is clicked. I don't really care about the button that's clicked, but you can imagine that if you have something that handles maybe hitting return, or hitting return when you're inside a text field, then you would go and get the text field that was clicked, or sorry, the text field that the method is, that the event is associated with the event, and then deal with it that way. So this is the method that is invoked when say hello is clicked, and we're going to say toast make text on this context. Yep, and we're going to say hello with 3 exclamation points. And let's just make that length long. We're going to show it. So Toast is a little API in Android that pops up a brief message. And For a long time, I thought it was a piece of dry bread toast. No, no, no. It's like you are, toasting with champagne. It's like, okay, well, once I thought about that, it's like, oh, well, that makes a lot more sense. And so it has a static make text method that will create a toast object. And you have to give it like the context in which it's displayed, and then also the text in the toast. And then you can say whether or not you want to display for a short period of time or a long period of time. And then you invoke the show method on the toast object that is returned by make text. And that's the thing that actually displays it. So now when we run our Android app again, we have a say hello button and we click say hello. And hello toast shows up here at the bottom of the screen. One really awesome thing about Android is that you can debug it really easily. It's just like debugging a Java app. So yeah, I set a breakpoint here in line 28, and I'm going to run the app as a debuggable app instead. It usually takes another extra minute or something. Oh, no, I guess not. Nice and fast. I click say hello, and now my debugger is invoked. I set a breakpoint. There's actually not too much to debug right here. And so I'm just going to continue on. And sure enough, there's my toast. It's about to go away. So this is a really important aspect of Android development. Well, first of all, what we saw is that we were able to use the design mode to add more widgets to our screen. And then we were able to associate, we were able to use this on-click handler, this on-click property of the button to specify, here's the method that ought to be invoked when that button is clicked. And so this is really the fundamental cycle of developing Android. You create a screen, you put some widgets on it, and you lay out the widgets using these constraints, or we'll see that there's also like a linear layout and things like that. And then you respond to events that happen. And we'll see, next time how like when you click a button, you can also go get information out of other widgets, like, oh yeah, this text field, go get that information and do things with it. And all that logic is in Java. So, the nice thing here is that you just need to worry about like invoking Java APIs here. It ought to feel more familiar to you. Any final thoughts on Android? Neat stuff so far, I hope. Yeah, cool. A week from tonight, we'll see a lot more. But in the meantime, you got Project 5 to finish off. Hopefully this will whet your appetite for after that. And we will do mobbing on Wednesday. And since we didn't have a break, and I made just through me trying to clean up my hard drive, let's be done for the night. So thanks everybody. Hope you enjoyed class tonight. Have a good couple of days. I will see you on Wednesday. More mobbing. Bye now.
Thank you. See you